Hello everyone and welcome back to Weather HQ. Today's video we're going to be talking about why meteorologists never seem to be right. That's the old saying here is, oh, meteorologists, they don't seem to be right. Like, they never get the weather right. They get paid to lie to the public here. Well, that might have been true in the 70s here, but as far as today goes, that's a lot less true than it used to be. I'm gonna go down and break through about 5 reasons why meteorologists never seem to be right. So reason number 1, the computer models can never reach an agreement. You're like, oh, but isn't this about meteorologists? Well, that's what meteorologists go off of, the computer models here. There are lots of models out there. You have some that go the short range and medium range and long range here. But reliability is also key too. I'd say out of all the weather models, only about 2 or 3 of them seem to get it right all the time or close to the right forecast all the time. I'm not going to go too in depth with what those are because that would require more explaining and that's going to really drag out this video. So, but maybe you'd like to see that in a separate video. Let me know down below if you would like to see that in a separate video about all different kinds of weather models. But anyway, yes, computer models can't reach an agreement. So let's take a snowstorm, for example. New York City, right? Okay, one model says that it's calling for 18 inches in New York City. It's right in the bullseye of the storm. Another model has it a bit further to the northwest, so some of that rain is going to work its way in. And New York City then is only calling for about 5 to 8 inches. Let's just go with 6 inches, all right? Which model do you believe at that point? Because you have a big range here. On one end, you got 6 inches, which is a typical average size snowstorm, and then you got 18, which is of historic proportions in a lot of cases. Well, this is a 5 days out forecast here. This is in this scenario, at least. You can't really trust a snow forecast 5 days out. Snow is not even the hardest weather to predict. That would be, I'd say, thunderstorms. But we're not going to get into that. We're going to stick with computer models not reaching agreements here. 5 days out, these 2 models here, one is more offshore and another one is more inland. That inland one is going to get that rain wrapped into it because of the warmer air. And then the one that's more offshore is going to have all snow because it is colder overall. So the thing is that you can't trust the forecast 5 days out. You just can't. Like, you can look at it 5 days out to see generally, like, oh, there might be some snow coming in 5 days from now. But you want to take it with a grain of salt because even 5 days out, it might end up being absolutely nothing. So now we're at 3 days out here in our little scenario. And 3 days time, they're coming a little bit more agreement here. Model 1, which is the inland model, has shifted a bit more off the coast here. So that means it's trending colder. But there's still not an agreement because that model even though that model's trending colder, it's only putting out about 9 inches of snow. Which is a lot, don't get me wrong, but compared to 18 inches, nothing, just nothing. And this other model has bumped its totals down a bit. Now it's saying 15 inches for New York City. Still significant. And then we get to the last 24 hours here. One model says 12 inches, another one says 14 inches. Pretty good agreement, right? So then we would develop our range. That's why we use ranges for snowstorms, because you can look at the bullseyes all you want to, but reality is it could snow anywhere in that range that's given. So like 10 to 14 inches would be the range that we would give there because you just never know. The models, they have a hard time agreeing A lot of times in the wintertime, you see that with those big nor'easters that go up the coast, right? Um, but yeah, that's basically it for the first point. The second one is the percent of area and not likelihood of precipitation. I'm going to explain what that means. What that means is when you see a percent chance of rain, most of us are thinking, okay, so there's like a 70% chance it's going to rain today. Might want to bring an umbrella or something to cover your hair if you're really conscious about your hair. But no, it actually is a percentage of the area that's going to see rain. 70% of your area, your forecast area, is going to see some rain. It's a rough estimate too. You can give or take a few. Maybe it's like 68% or 72%, whatever. But that's basically it. And that's a common misconception too. That's not communicated clearly enough with the public, in my opinion. Actually, it's not in my opinion, that's just a fact. Like, I actually didn't notice until a couple of days ago. And I've been studying weather for like 9 years now, going on 9 years. So that says a lot. The third point I'm going to go on is we tend to look in the long range when we're planning events here, but a lot of people generally don't check back to confirm. So you look at a forecast 2 weeks out on, the weather apps, they all say like 15 days now. Okay, you look at day 14 and you go, oh good, it's gonna be sunny and 75 degrees here. I think I'm gonna plan a trip. Well, not plan a trip, I think I'm gonna plan an outdoor, let's say, cookout. Okay. Then, let's see, you don't check back to confirm and it ends up downpouring bad rains and thunderstorms and it's windy here. You're like, what? My weather app said it was going to be sunny. You need to check back, people. Please, you've got to check back. 2 or 3 days out, even that can be kind of unreliable, especially when you're talking about thunderstorms here. Check back 1 or 2 days in advance to see if you can still do that cookout. It's a bit inconvenient for some people to plan something that close in time, but if you want to be on the safe side weather-wise, my honest advice to you, check back within 24 to 48 hours of the event that is going down that you're planning here. So if in that scenario, that person had to check the short range here, they would have avoided that issue and everyone would have been soaked and Sally's hair would have been getting ruined or Jake's Jake's hamburger wouldn't have been all soggy. I don't know. I'm just making up some stuff as I go here. I'm trying to spice it up a little bit. Okay, so the third and next point is, let's see. Oh, the fourth point. Okay, the fourth point is translating scientific language to general public language. This is something a lot of meteorologists struggle with. It's very easy to communicate with each other about significant weather events, but translating that so that the public understands and really gets it is a little difficult. Sorry, I don't know what. Anyway, so like I read the National Weather Service's forecast discussions periodically, especially when there's big weather events like snow coming or heavy rainfall events. The language on there's a lot of big words. A lot of big words that the general public would not understand. Translating that to general public language is a little difficult here. So you say something, let's take this for example, a mesoscale convective system. Most of you aren't going to know what that is right off the bat, right? Meteorologists talk about these all the time. Oh, look, there's going to be a mesoscale convective system plowing through Iowa tomorrow. Don't know what that is. Most of you don't know what that is. So let's break this down. Mesoscale, small. Meso means small. Small scale, convective, something that involves thunderstorms. And system, storm, complex, whatever you want to call it. So let's put that together. Small scale thunderstorm complex. And that's exactly what it is. A small scale thunderstorm complex. It's kind of shaped like a hurricane if you've ever seen a hurricane over land, or maybe a weakening hurricane. And but sticking to the topic here, that's all you would have to do. Translate those big. We have to translate those big words into little words. Well, not little words, but easier words for the public to understand. Because if I mention something like delta T values or theta E values, what does that mean, right? Like, what, right? Okay, so the last point I'm going to make is forecasting confidence needs to be clearer and taken more seriously. So meteorologists, they tend to try to tell you, like, but take this with a grain of salt because this could change. It's not always clear enough, or maybe the public just doesn't listen. I'm not sure. But when a meteorologist tells you that it's not set in stone, it's not set in stone. This is more common with forecasts that are 3 days or longer. So let's see. Let's take Hurricane Elsa, for example. The confidence in that, originally, this storm was going to go right for Florida and just impact the east coast of Florida. It did go for Florida, okay? It went for, we thought it was going to go to the east coast of Florida. It went to the west coast of Florida. And it took a sweet time, too, by the way. It got there quickly, but it slowed down, and then it shot up the east coast. Anyway, I digress. Yeah, the forecast confidence does need to be taken more seriously because if not, you're going to end up mad at the weather people. Okay? So you look at a hurricane forecast 5 days out, and you're going to like, oh, that's going to impact Miami, let's say. No worries. And you're up in, what, Tampa Bay. And then you don't check back until the day before, and then you're hearing everybody talk about, oh, Elsa's on its way. Hurricane Elsa's on. Tropical storm Elsa's on its way. You're like, I thought it was headed for Florida. You check back, and you're like, oh, the forecast has changed. It has changed so much. What? And then you're just shocked. You're like, but then you're like, it's a tropical storm, so I probably don't have to prepare that much, right? Wrong. You still got to prepare. The winds you might be able to handle, but the storm surge, that'll hurt. That will hurt your house, you, somebody you love. That will hurt. But yeah, going back. So you need to keep checking back when big storms are coming. I'm not saying to do it all the time, but yeah, just when those big storms are coming. Would it be blizzards, hurricanes, or severe weather threats? You need to check back. And need to listen when they say, but I think it's just a chance. All right. You'll hear, oh, we're going to have a big snowstorm. Oh, we're going to have a hurricane, and go, oh my God. Then nothing happens. Or worse than what expected happens. Gotta check back, people. I can't emphasize that enough. You gotta check back daily if a big storm is supposed to head for your area. Now, I'd say you could probably tune out if that storm was going a whole different direction. Like, if Elsa had went for Texas instead of Florida, you could have just tuned out. But it didn't. It went right for Florida, and it was underwhelming for a lot of people, but it did cause some impacts. Nonetheless, it's a tropical storm. What do you expect, right? But yeah. So yeah, that's my last point. Forecast confidence need to be taken more seriously for meteorologists and the general public as well. All right. Thank you guys for watching so much. Don't forget to like, comment, subscribe if you want more videos like this. I do apologize for the length, but I did have a lot to cover. I did spend like 5 minutes, the first 5 minutes talking about one point. I will try to be a little shorter, a little quicker with that in the future, but for now, yeah, don't forget to like, comment, subscribe, and I will see you all in the next one.